Hey guys, Mr. T here. This is another video. This is following on from graphing functions. So we saw that if you made the y values of a Cartesian plane equal to the value of a function, you're able to graph it. What we're moving on to is the idea that you can translate or move around or change the shape of an existing graph of a function by applying little changes to the writing of that function. So for any graph function, if you make the function of x equal y, slight changes that you apply to this side, the function of x, will actually result in transformations. So transformations, and hopefully you remember back to Cartesian coordinates, when you translate something, that's a kind of transformation that's moving it up or down. If you stretch something, that's another transformation where you squeeze it or open it out. And the last transformation is reflecting, so reflecting it in an axis or in a line. If you apply slight little modifications to this function, like add something to it or add something to the variable or times it by something, it just results in a transformation of the original graph, which was just y is equal to f of x. So it's not a completely new graph. The original graph, which you define at the start, y is equal to f of x, if you do a slight modification to it, often the resulting graph of that is just a movement or a stretch of the original. So the first thing we're looking at is translation, which is moving up or down. If you add or subtract a constant, which we'll call k for this video, from the value of a function, so if you added or subtracted from this f of x here plus 2, for example, or take 2, or if you added or subtracted a constant k from the variable function, so if you did y is equal to f of, and then in the brackets x plus 2 or x take 2, it's going to result in the translation of the original graph. The translation is a shift vertically or horizontally. So let's look at vertical translations to start off with, because they're easier to think of. If you add the constant to the result of the function, you're not adding the constant to the variable, you're adding the constant after the result, y is equal to f of x, and then add k to it. This translates the graph of y is equal to f of x vertically by k units. And if k is greater than 0, so if it's a positive number, the graph moves up. If k is a negative number, or if it's less than 0, the graph is moved down. So it's a whole bunch of words that I've just thrown at you, but let's see the reality of the situation. It's a bit simpler than that. By doing an example. So let's say the function of x was x squared, and we made it equal y, so we could graph it. So we make f of x here, which is x squared, equal to y. It's going to be shown in blue on the grid below. So that's what we've got here. I have graphed the function of x is x squared here by making it equal y. And what I've been telling you, that slight modifications to the function are going to result in just a translation. So what would y is equal to f of x add 5 be? So you are adding 5 to the result of the function. You're not adding 5 to the variable, you're adding 5 to the result of the function. And what I've just told you above is if you do that, if you add to the value of the result of a function, it moves the graph vertically by k units. If k is greater than 0, if it's positive, it moves up. If it's less than 0, if it's negative, it moves down. So y is equal to f of x plus 5 is going to be this same graph, but because it's plus, you're adding 5 to it, it's going to be moved up by 5. So I'm going to draw this in red. It's going to be the same graph, but moved up by 1, 2, 3, 4, 5. So, yep, it goes off the side of my grid, but that's okay. So there, this first graph that I'm drawing in red that, I have to draw it up here, is going to be y is equal to f of x, the original function, which is x squared, add 5. Let's see how easy it would be to get green. Alright, let's do the next one in green. So that's an example of a positive translation vertically when you've added 5 to the result of the function. What if you take 5? Well, I've shown you up above, if the constant is less than 0, the graph moves down. The constant is 5 this time, so it's going to move down 5. So 1, 2, 3, 4, 5. So 4, 9, 10, 11, 12, 13, 14, 15, 16. Alright, just giving myself dots to help draw the graph. So the last graph in green, where I've taken 5 from the value of the function, is going to be this graph in green, which is shifted down by 5. This is y is equal to the function of x, and our function of x for this example was x squared, but 5 has been taken away from the result of that each time, and that's why it's been moved down by 5. So that is vertical translations. Horizontal translations are the other kind of translation, and in this case you're not taking away or adding the constant from the result of it, otherwise the take k or plus k would be in the outside like it was before. Here you're taking or adding the constant to the variable in the function. That results in a horizontal translation. So if a constant k is subtracted is key here, from the variable input of a function, so from the actual variable itself, e.g. y is equal to the function of the variable x take k, this translates the original function y is equal to f of x horizontally, not vertically anymore. It doesn't go up and down, it goes left and right if you're seeing this, if it's being added or taken away from the variable itself. And it goes horizontally by k units. If k is greater than 0, if k is a positive number, so you're taking away a positive number, the graph moves right. If k is less than 0, the graph moves left. So you need to be careful here. I'm going to change my colors back to red. Careful here, because this example has been given to you as x minus k. If k is subtracted from x and k is less than 0, it's negative, it's going to look like x plus k, because a minus and a minusing a negative number will result in a positive. So if k is negative, the constant is negative, k will actually appear to be added. It will be x plus k to the variable. So just be careful there. You just remember that it's x take k, and you need to think about your positive and negative numbers when dealing with it. Alright, so let's have a think about this example. If our function again was x squared, and I graph it, I've drawn the graph in blue below. What's going to happen to that graph? What will that graph look like if 5 is taken away from the variable? So let's have a look back at our rules here. If the constant is greater than 0, if it's positive, the graph moves right. And because it's still x take away 5, it must be a positive 5 that was used. It must be a constant of positive 5, so it will move to the right by 5 units. So I'm going to do f of the function of the variable take 5 in red. 1, 2, 3, 4, 5 across. Alright. The video is getting long, so I'm just rushing this a little bit. So this graph in red is a graph of y is equal to the function of x minus 5 in brackets. Now green again, because I need to show the opposite example. What happens if it's the function of x plus 5 in brackets? So it's plus 5 because you were taking away a constant, but that constant was negative. It was less than 0. So it's actually moving the graph to the left by 5. So there. So this second graph in green is y is equal to f of the variable plus 5 in brackets. So this whole video, it's quite a long one, is an example of the translations that can be applied to a function and the function's graph. Hopefully that helps you out with the next set of exercises, and I'll see you in the next video.